You are developing an application for a hospital with three specific operational needs. First, the system must retrieve the absolute latest patient status updates, even when multiple simultaneous edits occur across global regions. Second, it needs to access patient vital signs data that is guaranteed to be either the latest version or the immediately preceding version. Third, it must retrieve final billing information for discharged patients only after all charges are fully locked in.
Your environment uses an Azure Cosmos DB for NoSQL account with a default strong consistency level and consistent indexing. You are required to override the consistency level at the individual query level to satisfy these specific needs. The available consistency levels are A. Strong, B. Eventual, C. Bounded staleness, and D. Consistent prefix. Which consistency levels should you implement for each of these requirements?
In my view, the correct approach to these requirements involves selecting specific consistency levels for each task. For the first requirement, retrieving the most recent patient status despite global simultaneous edits, I believe the correct answer is strong consistency. This level ensures linearizability, guaranteeing that every read operation receives the most recent write, which is critical for medical status updates where stale data is not acceptable.
For the second requirement, accessing vital signs data that is at most one version behind, the correct choice is bounded staleness. This consistency level is specifically designed to allow for a defined lag in data, ensuring that reads are not strictly tied to the latest version, but remain within a predictable, narrow window of freshness. This is highly efficient for monitoring data where absolute real-time sync is less critical than performance.
Finally, for retrieving finalized billing information after a patient is discharged and all charges are locked, I believe the correct answer is again strong consistency. Since this requires reading a definitive, finalized record without any potential for inconsistency, strong consistency is necessary to ensure the data is accurate. Note that consistency levels can be implemented multiple times as needed to meet various business logic requirements across your application.